Question 4, Part C. The graphs of y equals x minus 4 and y equals x squared minus 4x intersect at the points 4, 0 and a, as shown in the diagram. Part 1. Find the coordinates of a. To find the coordinates of the points of intersection of the line and the parabola, we solve simultaneously the equations y equals x minus 4 and y equals x squared minus 4x. Now, using the substitution method, we can form the equation x squared minus 4x equals x minus 4. Moving the terms on the right-hand side over to the left-hand side, we get x squared minus 4x minus x plus 4 equals 0. Now we have a pair of like terms, negative 4x minus x, which is negative 5x. So the equation simplifies to x squared minus 5x plus 4 equals 0. Now this is a monic quadratic equation. We can factorize the left-hand side. We get x minus 4 in brackets times x minus 1 in brackets equals 0. Hence x equals 1 or 4. Now the point of intersection where x is equal to 4 happens to be on the x-axis itself. So we already know the coordinates of that point. But we want the coordinates of point A, and that occurs where x is equal to 1. So using either equation 1 or equation 2, if we substitute x equals 1 into either of those equations, we can get the y coordinate of point A. So when x equals 1, y equals 1 minus 4. So I'm using the first equation here. And we get y is equal to negative 3. Therefore, the coordinates of point A are 1, negative 3. Part 2. Find the area of the shaded region bounded by y equals x squared minus 4x and y equals x minus 4. The line is above the parabola between the points of intersection where x equals 1 and x equals 4. Hence, the area bounded by the line and the parabola is given by the integral of x minus 4, which is the line, minus x squared minus 4x in brackets, which is the parabola dx, from x equals 1 to x equals 4. And they represent the x coordinates of the points of intersection of the line and the parabola. Now, expanding the brackets here, so this negative gets multiplied through to the x squared and the negative 4x, so that becomes positive 4x when we expand the brackets here. We can simplify the integrand and becomes the integral of 5x minus x squared minus 4 in brackets from x equals 1 to x equals 4. Performing the integration, we get 5x squared over 2 minus x cubed over 3 minus 4x from x equals 1 to x equals 4. Applying the limits of integration, we get 5 times 4 squared over 2 minus 4 cubed over 3 minus 4 times 4 in brackets minus 5 times 1 squared over 2 minus 1 cubed over 3 minus 4 times 1 in brackets. And that equals 8 over 3 minus negative 11 over 6, which equals 9 over 2. Therefore, the area is 9 over 2 square units.